What's up, gang? It's Caprice.
So today I'm going to talk about sources of ionizing radiation in the environment. So there's actually two types, which is natural and man-made. So the examples of natural are cosmic rays and background radiation. Examples of man-made are nuclear accidents, nuclear tests, use of radioisotope for medical purposes, and background radiation. So now for cosmic rays. Cosmic rays are high energy protons and atomic nuclei that move through space at nearly the speed of light. So it originates from the sun, outside of the solar system, and from distant galaxies. It's also known as galactic cosmic rays. And now for background radiation. Background radiation is made up of various types of ionizing radiation in the environment. So it is released from various sources like natural and man-made sources. So some of the sources are cosmic rays and radiation, radioactive radiation from natural radioactive substance in the surroundings. So now for unit of dose rate measurement for background radiation. So before this, humans knew that ionizing radiation that is absorbed into the human body will damage the body cells. So because of this, biological effect from ionizing radiation on human body is measured in a quantity called dose. So a dose of one
Sievit.
Is equivalent to 1 joule of ionizing radiation energy that is absorbed by 1 kilogram of living tissue. So the unit of background radiation dose that is commonly used is known as microsievert per hour. So now I'm going to talk about safe background radiation dose in daily life. So for the normal level or the safe level is 0.2 microsievert per hour. And some of the examples are TV or computer, which is ionizing radiation that has 0.01 microsievert per hour, or flight, which is cosmic rays and have a 0.003 microsievert per hour. Okay, so for risk from exposure to natural ionizing radiation, absorption of ionizing radiation by the human body imposes health risks which are affected by the dose of ionizing radiation received, meaning the more dose of ionizing radiation received equals to more health risks that you will get. So I'm going to talk about some source of ionizing radiation dose received and their safety measures. So for background radiation, you must use appropriate protective equipment such as spectacles fitted with anti-ultraviolet film. So when taking X-ray, you must take X-ray with doctor's prescription. For television, you must make sure the distance between you and the television is at least 2 meter. And for food contaminated with radioactive substance, you must not eat food that is produced in contaminated areas with like a place that is contaminated with radioactive substances. For cosmic rays, working hours of a pilot are limited to a certain period of time because the pilot is exposed to cosmic rays. Meaning they cannot fly the plane like daily, they must have a rest hour because they are exposed to cosmic rays. So lastly, for examples of absorption of ionizing radiation exceeding the safe level and safety measures that need to be taken. So for this one, as most cosmic rays are absorbed by the atmosphere, the dose of cosmic rays on the surface of Earth is normally safe level or normal level, which is 0.2 microsievert per hour. So if the person goes higher from the surface of the earth, the stronger the cosmic rays that he or she will receive. So for example, airline crew like pilots, stewards and stewardess will normally receive cosmic rays that exceeds the safety level. So because of this, their working hours in the sky are limited to a certain period of time. So that's all for me. I hope you understand and enjoyed what I presented about just now. And
Ito yung video untuk kali ni.